Sorry for another fakeout. Forget trying to do this project on Intel CPUs. We've changed our mind and we'll be going with Cuda. Unless the tiny chance of getting access to the cards of one of the companies in the AI field that we fancy materializes, we'll be going that route. In our last video, we remember hyping AMD and Intel. But at this point, we are thinking whether we are simply wrong about GPUs not being the future and want to test our view. The last time we programmed them was in 2018, so our experience is heavily biased by the programming we did in that time. At the time, the GPUs were only toys in our view, and we expected in a couple of years that proper AI hardware would arrive to displace them, but the complete opposite has happened, and the position of GPUs in the AI hardware hierarchy has only gotten stronger, and we feel that the claims made by Nvidia's competitors at this time are more bluster than reality. Last week, we've spent half a week studying data parallel C++, and for the other half, we decided to finally give Cuda another chance again. We thought that maybe in 2023, it was time to update our beliefs rather than stick to our 2018, so we watched talks and went through the entirety of its user guide. And to be honest, we like what we see. In 2018, GPUs were toys, but in 2023, the latest Gen Hopper chips are 50% of a real AI chip. We mean this as a compliment. We have a certain rule on favoring future hardware. Any companies making it must support cheap consumer hardware. Though the MI300 chip by AMD is getting hyped recently, AMD doesn't actually support programming the consumer versions of them like Nvidia does with Cuda. So we are going to ignore that because even after it arrives, it is going to take AMD years to develop the ecosystem, and we sure as hell won't be renting very expensive cloud GPUs just to help them achieve that goal. Pretty much all AI chip companies are like that today, so they don't deserve our interest. Companies that ignore the little people and just go after the big fish deserve neither. Interestingly, Intel has put significant work into making the libraries for its own ecosystem. And if it can come up with hardware competitive with Nvidia's, then it might be worth giving it a chance. As much as we like what we saw in the data parallel C++ book, we won't be concerning ourselves too much with it right now. Enough of those other companies. Originally, our interest in data parallel C++ was because we might be able to write portable code for both the CPU and the GPU. But even though that effort is laudable, it wouldn't give us access to Nvidia's libraries, and that is a huge thing when programming Nvidia GPUs. Right now, it is just an attempt by Intel to siphon the Nvidia audience and lock them into their own ecosystem. It doesn't matter if it is open source if it only has libraries for Intel's hardware. It isn't exactly the conclusion we would expect to come to in late 2023. But in the absence of anything better, what we will do is pursue our goal on Nvidia GPUs. We will implement the poker game and the ML library in their entirety on the GPU, without the inefficiency of going back and forth between the host CPU and the device. This is a pretty obvious conclusion, and now that we are saying this, the only thing we have to ask ourselves is why haven't we done it earlier? Why have we spent 2 months of our life learning to program FPGAs only to abandon it all? For one, as we have said, our experience with GPUs ends in 2018. Back then, for example, it wouldn't have been possible to implement the game and the library in its entirety on GPUs. Ironically, the key features we would have needed to do that would only be introduced around the time we had thrown in the towel on our first attempt at making ML work the way we want it to, in late 2018. And the libraries that we'd need to do that were still young at the time. We'll go into what these features and libraries are in the next video. Abandoning FPGAs wrecked us mentally. So right now, we are stressed and in need of a break. We'll see you soon.